So hey guys, welcome back to my channel, and today we will be discussing another question from GATE 2025 of computer science, which is of operating systems. So it is question number 36 from CS1 paper. So the question says, consider a memory system with 1 bytes of main memory and 16k bytes of cache memory. 1 bytes of main memory, 16k bytes of cache memory. Assume that the processor generates 20-bit memory address and the cache block size is 16 bytes. If the cache uses direct mapping, how many bits will be required to store all the tag values? Assume the memory is byte addressable. Now, just for your information, let me tell you that byte addressable means that one address is referring to 1 byte of memory. Can you get my point? Now the thing is that we have 1 M of main memory and 16k bytes of cache memory. Now since main memory is 2 to the power 20 and the block size is 16 bytes, so the number of main memory blocks would be 2 to the power 16, and similarly the number of blocks in the cache memory would be 2 to the power 10 upon 2 to the power 4, giving 16 into 2 to the power 10 upon 16 into 2 to the power 10 upon 2 to the power 4, giving us 2 to the power 10 blocks in cache memory. Since the memory address is of 20 bits, we want such that those 20 bits are accurately helping us map whether a particular block is in cache or not. So just for your information, the cache memory address that we have has 3 parts. It has a tag part, it has an index part, and the third part that it has is offset. Now let me just quickly tell you what all these 3 parts mean. First of all, offset means that where in the block the address is, the particular block that we are referring to. Now what does index mean? Since we have 2 to the power 10 blocks in the cache, we don't know exactly which block we are referring to when we have a particular cache address. So index is for helping us identify which block in the cache are we referring to. So can you tell me from this thing how many bits we would be needing for cache? Cache's index basically. So I guess we would be needing 10 bits because since the block size is 16 bytes, we would be needing 4 bits for unique identification of where in the block is the address. Now for tag is basically for comparison of an address from main memory to comparison of an address in the cache memory, just to ensure that whether a particular block is in cache or not. So that is what is meant by tag. Now if we come back to our question again, see the last line. If the cache uses direct mapping, how many bits will be required to store all the tag values, like all the possible tag values that we have? Now from this knowledge and the 20-bit memory address is there, can you tell me how many bits will we need in a specific address of a cache? 6 bits, because 20 minus 10 minus 4 equals to 6. And 6 bits for each address in tag. Can you tell me how many bits will be required? I guess 6 into 2 to the power 10. Because per tag we need 6 bits for all the possible blocks. For all the possible blocks, we would be requiring 6 into 2 to the power 10. So this becomes our correct answer. So thanks for watching this video. If you found something useful or valuable in this, do share this video with your friends, and please like